A common task we'll need to perform as programmers is reading input from a file. In this video, we're going to take a quick look at how to acquire text input from files. Before we start though, a quick note. I've gone ahead and told Java that sometimes our main method is simply going to throw I/O exceptions. Our file writer and file reader object here both can create a number of I/O exceptions for a number of reasons, like if they can't connect to the files they're supposed to. When writing actual programs for actual applications, we always want to make sure to catch and handle our exceptions in a reasonable manner, only throwing them upwards if it's truly necessary. But we're just going to throw everything here because we're doing this to learn, and we don't want to be bogged down right now wrapping all of our code in try-catch blocks. So, about the code we already have. I've declared for us a file writer and a file reader object. File reader is a sister class to file writer. It's capable of, believe it or not, reading text input from files. And it's constructed in a very similar manner. It expects to be given a file to be associated with it throughout its life when it's constructed. Rather than simply giving our file reader and writer paths to these files, I've chosen to create file objects. The Java file object is simply a reference to an existing file, and we tell that file what file it references when it's created. In this program, we're going to be using inputfile.txt, which contains some information. And we're going to be using outputfile.txt, which currently contains no information. Our goal is to move the information from input file to that output file. File writer and file reader both have methods that are going to be useful to us here. Our file writer has the write method, which we know can be used to put information into a file. Similarly, the file reader has the read method, which will allow us to acquire information from a file. If we simply call these methods in sequence and run our program, we'll see that information is actually taken from input file and put into our output file. Unfortunately, only one character appears in our output file, the first character of the input file text. It would appear that our file reader's read method only acquires the smallest acquirable piece of text information. That's not a problem for us though, because we are programmers. We can simply loop through using the in.read method to acquire all of the information available to us in that input file. However, we can make life a little easier on ourselves by also wrapping our file reader with a buffered reader class. Similar to the way we can wrap file writers with buffered writers, we can wrap file readers with a buffered reader. Which will allow us to collect varying lengths of input at any given time. Even more so than wrapping our file writers, it's almost always a good idea to wrap our file readers. The buffered reader also serves to protect the file reader from files that are too large for the file reader to hold in memory at one time. This doesn't happen very often, but when it does happen, it can be a pretty confusing bug. And because the buffered reader only looks at portions of the file at one time, it's protected from that instance. Our buffered reader is also going to let us use the next line method so that we can collect information from our input file on a line-by-line basis instead of a character-by-character basis. Either way though, our while loop is going to look pretty similar. The only real challenge here is that we need to know when to stop looking for information in our input file. To figure this out, we're actually going to put some functional code in the conditional portion of our while loop. We're going to assign a value to this new input string variable, and that value is going to be in.nextLine. The reason we want to do this assignment in the conditional portion of our while loop is so that we can then check what value was assigned to new input. Because if new input was assigned no value at all, it means that we've reached the end of our file. Oh, and the method is readLine, not nextLine. If new input does have a value, if the variable is not null, then we know that we've read in legitimate text from our file, an entire line of legitimate text actually, because we're using the readLine method. If this is the case, we should add this new line of text to our input string. And when we're finished executing our while loop, when new input is assigned the value null because there's nothing else for our reader to read, we should print out this string that we've been building. Now, because our buffered reader's readLine method specifically reads lines of text, it doesn't append the end line character at the end of them. So we'll have to do that on our own. So we've executed this program. Let's go to our directory and see what's been copied over to output file. And there we go. Input file and output file now have identical contents. That's really all there is to basic file reading in Java. A couple other things to note though. Just as we can wrap a file reader with a buffered reader, we can if we import java.util, wrap a buffered reader with a scanner. This would allow us to use the scanner class's methodologies to acquire only portions of the text we were reading that match certain patterns. It's also important to note that the file reader and its wrapping classes are only appropriate when we're reading text from a Java file. If we want to read binary information, we're going to use different classes. More on that when you learn about serializing objects in Java. Thanks for watching.